How see, if you want, if you you mess up, then I think like that what whatever you want to think that okay. Anyway, okay, fine. What do you want to do after you had a bunch of classes already? We had the right help from here. About what can we do from class? So is there anything more to do? Like more problems? Do you want more problems? Huh? You want more problems? People use more problems. Do you agree that we need to do more problems? Because you guys are struggling with problems, I think. The theory part is not the problem. Is that right? Okay. But I think we still did a lot of problems. We did quite problems. But obviously we cannot, in per topic, we cannot do 5, 6 problems not because we have to finish this. So whatever is necessary, I'm doing it. Remaining, I'm hoping that we will do it. Solve it. But I'm happy that most of at least want the test to be all right easy. I'm not in the question. Still doing it for the test to play. Last year, did they have the question that we do? You have? Can I take it? I did not take it. What? Yes, I will put it in. Yeah, there don't spend a lot of time on it. Do you have another charging point anything? Or I just think let it have to go ahead, so I'll not spend a lot of time on this. Okay? I just want to go through it. There are 19 questions in all are compulsory, blah 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 blah, refractive index of both substances. Analysis of prior and so the angle of refraction will be maximum. Quite easy, no? Huh? You know the refractive index this thing, sign. Okay. So all of them, the angle of incidence is same. Refractive index is given. So theta r you can kind of you get an idea of which is more or which is less. Right? It's quite easy. When the opposite surfaces of a slab are not parallel, the emergent angle and the incident angle is related and okay. Did anybody get this right? Second question, when the two opposite surfaces of a slab are not parallel, the emergent angle E and the incident angle are related as nobody has question paper, I think. Okay. Okay, fine. I'll check it out later. Don't we'll not waste time with that. We'll otherwise our class time. We'll do it later. I'll just start with the class. But any which way, you guys felt like it was doable, correct? Fine. That's all. So what you can do is, if necessary, no, this is done. I'm doing another email, which is that light and electricity. I think last time we did electricity. Just like not this one, not this PPT. Electricity. If necessary, what you can do is next week again we can do a bunch of problems on that unit and this electricity one combined. But you have to come prepared for such a class. If you don't read and come, I hear me showing you problems, it's useless because you're going to be turning pages. I don't want that to happen. You come prepared with the knowing the equations, you come clear with the concepts, Then we'll sit and we can do the problems for 1 hour straight. Guys will get that way you will get a complete idea when you're doing it. Okay, you can dive into the problems. Otherwise, what will happen? Here you are trying to clear those concepts, okay, which we have already studied. You are trying to look at those formulas. Don't do that. Is that okay with everyone? Fine. Like yeah, electricity, and we started electricity, no, last class. How far did we reach? We talked about resistance, but did you guys go through the resistance ka part? Okay, you don't put all this at the start. Okay, later on you edit it out. Because but last class we had all done. That is how many of you all went home and revised these things that was done in electricity? Anybody went through it once at least? Okay, good. Thanks for your honesty. But do it, okay? Because, bro, you need those sponsors for today, bro. If you're not, you do not look at it, you don't remember it today. If I do, you will be turning the pages and you'll be looking at what we did in the last class. Please. Okay. Yeah. Fine. Anybody remember a particular law which was named very weirdly? Very good. Thank God. My laptop, if I try to open it, will be fine. What? Fine. See, you are absent in the first few classes. You have to go through them, those things. You can take the help of a friend, ask any one of them to sit and teach you. Huh? You study on your own, fully confident. When do I do a test for you? When should I do a test for you? Yeah, because you're so confident. Anytime, I say tomorrow. Fine. So we looked at resistance. Okay. We looked at a law called Ohm's law. Can anybody tell me what the equation for that is? Come on. The Ohm's law, it uses an equation. V is equal to. Why this is not right? V is equal to IR. Okay. V is equal to IR. The guy found that voltage was proportional to current. When he increased the voltage, somehow miraculously current was also increasing. What is voltage? Potential difference. It's like a difference in pressure of sorts. Okay, you have to go through stuff after the class is done. Otherwise, you'll be clueless like this. Okay, the potential difference, the more the potential difference, it's like we are putting a difference in pressure of sorts, you can say, imagine it. There's a wire, there's a difference in the charges. The difference in the charges is so high that charges try to flow from a place where the density is high to a place where the charge density is low. So that it tries to balance it out. When the charge is flowing, this is per current. Clear? Higher the potential difference means higher the difference in the charge concentration across both ends, the more the flow in the charge. So the current will be more. And this was proportional to this. And when we remove the proportionality, then we put the constant of proportionality. What is the constant of proportionality? What? Resistance. Excellent. What is resistance? Basically, it is a property of a material to resist the flow of charges. Simple. Clear? Okay. So I try to take my laptop and use the phone. See, if you guys are understanding the concepts in class very clearly, go home and spend just 2 minutes going through the textbook. You'll know everything that was done. Okay? Because otherwise, life becomes very difficult for you and it becomes doubly difficult for me. And if this is the case, then I'll have to keep getting slightly more strict. You want me to get strict? Something like this, sir. Okay. Fine. So today we are going to look into an idea that is the factors on which the resistance of a conductor depends. Okay. All right. So resistance in a material, it depends on various factors. Okay. For example, let me give you an idea. If this is a road and this is you and you're sitting inside a car. My car looks like this. It looks ugly. But that's fine because all cars look like this in this road. Okay. Fine. Now, my car wants to go from here to here. Okay. But there are two cars out here. So I can say that my car is going to face some resistance. Okay. It wants to go. This car is called A. Let's say it wants to make. Let me rewrite that. My car is called A. It wants to go to the other side. There is some resistance on the road. If I increase the length, okay, let's say I will increase the length. I will make it twice the thing. I will replicate the same thing out here. But when I am replicating the length, I am increasing the length, the number of cars is also. So the problem is that when the length is increasing, is my resistance decreasing or increasing? It's increasing. Because the barriers are becoming more. Okay, because there's some barrier, barriers. Okay, yeah. So I can say that R, my resistance, is directly proportional to L, length, fine. But now what I do is I send these vehicles into another road and I have increased the width. Before this was a single lane road, this is a 3-lane road. So this car will go out here, this will go out here, some other car will go, it will go maybe out here. So the number of cars that were before me, they are being distributed along the area. So increasing or it is decreasing? It is decreasing. Excellent. So R is directly proportional. Similarly, if I take a wire, if the length increases, my resistance increases. But if the area decreases, so R is that inversely proportional to area. This much is clear? Fine. So if we put this together, I can say R is directly proportional to L by A. Okay? You can write this down. Okay? Okay? So no sleeping. So it is directly proportional to L by A. So there is proportionality. So if I remove proportionality and I make it equal to what do I have to have? Constant of proportionality. So here my constant of proportionality becomes a quantity called rho. Okay, it's given, it's a Greek sign. It's given like this. It stands for density as well. They are used for different things under different context. Okay, fine. So write this down. And this quantity called rho is called resistivity. Resistivity. Okay. Electrical resistivity, and its unit is given by ohm meter. Okay. Fine. Its unit is what? Ohm meter. Can anyone tell me how I can arrive at this ohm meter from this equation? The SI unit of rho is ohm meter. Can anyone tell me from this equation, if I don't know rho's SI unit, how I can arrive at that? Can somebody? It's a very simple math. So, okay, let me say R is equal to, what was it? Rho L by A. Everybody notice that now. It's an important equation. You need to know this. Along with Ohm's law, V is equal to IR. Using this, you're going to solve a bunch of problems. You have to remember it. It has to be drilled inside your brain. Okay? So what is the SI unit of R? Resistance. You remember, this is resistance. This is resistivity. Both are different things, but similar concepts. You may ask, what is the idea? Right? So the idea is resistivity is a material property. Okay, meaning let me call this one resistivity. It is inside the road only, it is built that some values are going to be there. Okay, I mean, increase this in length, then because the material has value inside it. It is going to act. And this is my total. You get it? Resistivity might be a material property which defines how much the material contributes. Now this can be multiplied and this can be divided by such so and so things, right? And that at the end I'm getting a total resistivity of the material, that is called resistance. You getting an idea? If this guy is resistivity, we call it resistivity. Here also it's called resistivity. Here, but for me, okay. So resistance is the total quantity. You get it? So in my Ohm's law, what is coming? V is equal to I. So that was total. One and one resistance. Get it? Can you if you want in your own words in a way that you understand? Note something. And now, if I want to arrive at ohm meter, what can I do? Can somebody tell me? I just want to get the SI unit of rho. So rho I keep on one side, everything else I take on the other side. I can get something like this, right? Can you tell me their individual SI units? R will be ohm. Excellent. A will be area. Meter square. Area length is meter. Area is meter square. Length into length, but side into side. That's what is square or whatever the formula is, right? Meter square. And what is length? Meter. So my meter in the denominator here it gets divided. What will be meaning? Okay. Any doubts are here? Good. So having known this much, can we do a few problems? Okay. Yeah, tell me. Okay. So write down this question. How much current will an electric bulb draw? I repeat. How much current will an electric bulb draw from a 220-volt source if the resistance of the bulb filament, I repeat, how much current will an electric bulb draw from a 220-volt source if the resistance of the bulb filament filament is 1200 ohm. Is 1200 ohm. Okay. How much current will an electric heater coil draw? This is another set question. How much current will an electric heater coil? How much current will an electric heater coil draw from a 220-volt source if the resistance of the heater coil is 100 ohm. Okay, I'll repeat the entire question again. The first question or the first sub-question is, how much current will an electric bulb draw from a 220-volt source if the resistance of the bulb filament is 1200 ohm? The second sub-question is, how much current will an electric heater coil draw from a 220-volt source if the resistance of the heater coil is 100 ohm? Okay, very direct questions. You have the equations with you. First, note down what you have. Note here. Someone is very direct. To be able to do it. If you understood how to solve it, let me know. Did everyone get how to solve it? Understood? Understood? What is the confusion? V is equal to IR. What is given to you? First question. Those are two different questions. V equal to 220. And what else is given to you? R is given to you. So V is equal to IR. So if you want to, what you would find? I. So V by R, and you get I. Very direct. Then both are that two different, okay? Uh, what idea? The reading is math. Math you have to work on. Math is A. But remember we talked about because you need one to be one. But you guys got it. But how to the math? Fine. Then we'll work it out at home. We don't have time. But concept is clear. V is equal to IR is clear. The problem is that maths is not happening properly. Correct? Huh? You got it. Awesome. Okay. Maths, you guys will have to figure it out and learn at home. I cannot teach you maths also here. Okay. Then it becomes difficult. Okay, no, but everybody understood how to do it, right? Understood how to do it? Division. Simple. And that's all. I was wondering why people are taking so long to do division. And okay, fine. We'll write note on one more problem. Okay. The potential difference between the terminals, I repeat, the potential difference between the terminals of an electric heater, the potential difference between the terminals of an electric heater is 60 volts. 60 volts. Okay. It draws a current in 60 volts. It draws a current of 4 ampere from the source. I repeat, the potential difference between the terminals of an electric heater is 60 volts and it draws a current of 4 ampere from the source. What is the current? What current will the heater draw? I repeat, what current will the heater draw if the potential difference is increased to 120 volts. I repeat, what current will the heater draw if the potential difference is increased to 120 volts? I'll repeat from beginning, okay? The potential difference between the terminals of an electric heater is 60 volts and it draws a current of 4 amperes from the source. 4 amperes. What? What did you say? The answer? Did you, from where did you get this? Textbook. Yeah. But I want you to figure that out. Do it properly. Close your textbooks, okay? Close your textbooks. These are problems from your textbooks only. We are going step by step so that you understand the concepts. Okay? Question is clear, no? No repeat. Come on, guys, get to work. Same formula. Done. Is 120 or 150? What did I write wrong? This is correct. Second part. Find out. Okay, fine. Everybody's clear with these things? See, I cannot teach you guys mathematics. Okay? Physics, I can teach you. Maths, you have to figure it out. And I cannot spend too much time on that. Next question, come on. Okay, quickly. No, the resistance of a metal wire, the resistance of a metal wire of length 1 meter, I repeat, resistance of a metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. The resistance of a metal wire of length 1 meter is 26 ohm at 20 degrees Celsius. If the diameter of the wire, if the diameter of the wire is 0.3 millimeter, if the diameter of the wire is 0.3 millimeter, what will be the resistivity of the metal? What will be the resistivity of the metal at that temperature? What will be the resistivity of the metal at that temperature? Okay, fine. Everything is given to you. Everything is known to you. Make sure you figure out the units. What is the diameter given? Maybe it's in what millimeter. Million one millimeter, 10 to the power minus 3,000. So you basically divide it by 1,000. 0.3, whatever, 0.3 or 0.03, 0.3 divided by 1,000 meters. Okay, add that. Into the thing. Correct, no? So, fine. Now, solve it. This equation is also given. Resistivity equation is given to you. Right first, always write down what is given to you in the question. Okay? Then write your equation. So 1 minute. Is this the equation that we are going to use? Huh? No. Why? Yeah, basically resubstituted same equation. So this is the one. The same thing. But you know the area. Can you find the area? Area is not given. 1 minute. Pi r square. No? Your area is pi r square. Correct? No. Is there any doubt about this? You don't remember this equation. Okay. Area of a circle, pi r square. It's a wire. Wire area means it's a circle. Diameter is pi r square. But you have the diameter. So what you do, you use the divided by 2, or you'll multiply whatever like you can do this basic. Just, okay, you can do it in your own way. I've done it in this way. Does this make sense to you? It is pi r square. Radius is nothing but diameter Q2. If I put this earlier, diameter will also be squared. Kilometer 2 will also get squared. Okay, this value is r. So if r is getting equal to 4 is r square. You can do it this way, or your diameter value which again you can just divide it by 2 and you can put it as here. No index. Okay. Yes, everything, whatever is in millimeter has to be brought to meter. See, I've done it as here in the previous slide. I've just shown this to you. It has to be in meter. Whatever, whichever you weigh it, that depends on you, but it has to be brought to meter. Okay. Okay. Always remember this. Anything in millimeter for calculation purpose, bring it to meter. Okay. Standard units always. Okay. Did you guys and you want to minutes and we want and I think there has to be basic math. Okay. So is that something or 28, huh? 78. Not 78, it's 1.84, something around 10 to the power minus 6 ohm meter. Go through it, do the math. We know But everybody understood how to do it, right? The rest is multiplication, division, and all. If that I have to teach you, it's going to be very troublesome. Fine. So the thing is, like I showed you previously, about the road example and all. That is called you understand the concept of resistance, right? But the thing is, the resistance can the system. If I want to create jam, I can create jam. No? I can put some barricade. I can put something or something. If I want it, correct? Similar to in and we can introduce a component called the resistor. And we seen resistor to be made a small resistor. It's an electrical component. Okay. Almost anywhere, if you even Google resistors, you'll get different types of resistors that you can see. I don't want to go into it right now, but it's a small thing. You can insert it wherever in your circuit, and it will give you some sort of resistance. Now, why can I also bring resistance? Why? The idea is very simple. Correct? 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 Proportional to 1 by S. Basically, if R increases, I will decrease. It is inversely proportional. Basically, the idea is R is inversely proportional. If one increases, the other decreases. If I have a component and the supply is very high, and I have a component, I have a bulb, it consumes very little current. What I do, so that of a high decreases, so that the bulb is not damaged. Because of the high current, the bulb might explode. Is that clear? So according to particular increase my resistance or some resistance to the flow, I want that flow that for that particular application. Is that clear to you all? Fine. So what I can do is now I can add systems of resistors. I'll have one resistor which looks like this. Let's say I have a particular circuit, and this is my battery. Okay. You guys remember this symbol and all? This again, I don't have to remind you all, right? Fine. So I can do, this is one resistor. I can add one more resistor, and I can add another resistor like this. Like how our traffic police, they put 2-3 barriers. You have to go like this. It will have a combined effect. Okay. Now there are two ways in which I can combine resistors. Okay. One is like this, side by side. This is called series. What is it called? Okay, I'll draw it out again. This is called adding in series. Okay, is that fine? And there's another way. Called adding in parallel. Okay, series combination and parallel combination. Is this much clear to you? Okay. So the interesting thing about this series combination is, here actually, so here The voltage is there. No, one particular voltage is applying on here. V, let's say, across this whole thing. Okay, fine. I need to wait for this also. The best way to understand it. Fine. Okay. If I measure the voltage across this, voltage is always measured across 2 points. Understood? Voltage, potential difference, potential are the same thing. Remember the concept? Last time, the clear. It's a very clear like this. This time everything is very clear. There's nothing we said. Okay. So what 2 points is the potential difference for it is that but the number of chances going to point. Yeah. Okay. So what is happening? The voltage actually in series combination. Excellent. The voltage gets split. If I have one voltage here and I put what is this device called which measures voltage? Voltmeter. Remember? Voltmeter. This total voltage and there is one. I put one voltmeter on here. I call it V1. I put one on here across this two. V2. I put one on here. V3. You're understanding this? I'm putting one voltmeter across this. What I'm saying is that my total V is equal to V1 plus V2 plus V3. Understanding? The potential difference is drop like voltage across this plus this plus this. It is getting split into three. Understood? No? But surprisingly, my current is the same. Understood? If I put here current I and if I measure current here, I will find that I1 is equal to I2 is equal to I3 is equal to I. It's same, all thing, it is not changing. Okay, is this much clear to all of you? Whoever is clear, raise your hands. Okay, fine. Now, the ulta is happening in parallel. Okay, if I put one, what I can do is if I put one ammeter here, and I put one ammeter here, okay? I call this A, this will be 1, 2, 3. Okay, you are understanding the point, right? This is A, okay, B, ammeter across the, it is kept in that point. So I find that my current is measured, and I find that my I is equal to I1 plus I2 plus I3. But my voltage range is this much clear to you all? Is this much clear to you all? Okay. Can everyone note this down? Is this the? Yeah, note down this and with the formula. You know what? 80 pages. On one page you write this, on the other page you write this. Okay. Fine. On one page you write this, and on another page you write this. Leave space down. We are going to continue. Let me know when you guys are done. Let me know when you guys are done. Okay. So two different cases. Okay. So first case, and you have written the equation, right? So now what we want to do is, for the first case, for this case, do we know Ohm's law? V is equal to IR. So what will be V? V is equal to IR. Can you substitute that for all this? Right? V IR is equal to IR1 plus IR2 plus IR3. I'm constant, right? That. Or you can write as I1 R1 plus I2 R2 plus I3 R3. But then you write equal to I2. You're getting what I'm saying? V is equal to IR. So can I write this V as IR? Down can I write is equal to IR? Yeah. Is equal to what is V1? I1 R1. IR2 is equal to plus what is V2? I2 R2 plus what is V3? R3. Now what do we see? I constant. If same can you handle? You can like that. Or you can see. Do you know taking common and all that? Listen. See. Tell me the equation. V is equal to. Okay. V is I R. This is plus IR. I is there. Do you know the concept of taking common outside? So it will be I into R1 plus R2 plus R3. Here I R. Here also is there, here also is there. Can I cancel? Cancel means if I bring this to the other side, it will be I by I. Cancel one. Same thing. Okay? So what is the end it will be what? R. R is equal to R1 plus R2 plus R3. So if I am doing, I have a bunch of resistors. Okay, write it down. Write this down first. Okay. If I have a bunch of resistors and I add them in series, what is going to be my net resistance? It is the sum of all the individual resistance. Getting the idea? Now we will do the same for the other side. Okay, the parallel. Come on, can you do this for parallel for me? But you have written this down, right? You understood what we do. But here what is constant? B. Don't wait. So I will be V by R. Yeah, so this will be V by R, this will be V by R1 or V1 by R1, V2 by R2 by R2. Write that down. Then what you are taking common from that entity, you are taking common. So take that common and cancel it. And tell me what is your final expression. This one is long. What are they? So we have to come on and then what is that we think. So this is V by R, no? Fine. What is this? V by R1. Actually, you can write it as V1 also V2 V3. Okay, understand? But what we have V is in this case V is constant. If it is constant, means it is equal. Okay, so V1 is equal to V3 is equal to V. So is this one clear to you? Okay. So I can write this as V by R2 plus V by R3. Okay. So here my V by R is there. On this side, now I'm taking V is common on all these cases. So V will write as this outside into 1 by R1. Because we have come out, it will be 1 by R1 plus 1 by R2 plus 1 by R3. Again, I can divide it or I can cancel it. If I take to the other side, it gets cancelled. That is the best way to do it. I think I'll bring it to the other side. I'll cancel. And I'll have V by R V get cancelled. So on this side, I'll have 1 by R is equal to what is 1 in R? So you is this one clear? 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 So what we conclude in the first case, whether the activity is the equation is direct, but if it is inverse, it is inverse. That the relation is different. Correct? So what we can do is accordingly, if I have a set of resistors, not only if I'm using charge, I want to bring some resistors. But what I can do is, if I want that value, I can manipulate that using a bunch of resistors. Maybe 2 resistors and 1 resistor. So my combination this integration should be direct addition in my family in my addition. So in some way I will do the math so that I can get the exact number that is okay. Is that clear to all? So my net resistance will be R. If it is R plus I want so that I want now can I find my current is it okay. Is it that okay? Fine. So please go through this after today. Go through it. If it is going too fast, you can let me know. If I should slow down, if I should do more problems, if there is some, if you find some problem in the teaching, All of this you can write it down and quickly we don't have a lot of time. So some more problems, but today we did a bunch of problems. So that is fine, right? Like this only, you want some 2, 3 problems in that. Okay, so we I want to do some or and you guys get it for dear lunch. Ask some questions like what you have to ask us. Okay, for I think it will be better for no? Okay, but if I do that, no, 15 minutes will move. Yeah. We can do that. No problem. Okay, no issue, buddy. Take care. Read and come, okay? Next class. Read and come. From songs again. We are going to give you. Okay. Yes. Is that-